Finally, the curved claws of a Spinosaurus are better for catching prey underwater than trying to walk on land. A Spinosaurus could hook an unsuspecting fish swimming by. However, some people push this idea a little further. They thought the Spinosaurus spent long periods of time hunting in water. Some reptiles had already adapted this way by the time the Spinosaurus evolved. Plesiosaurus, for example, were strong, long-necked marine reptiles who survived the Triassic extinction before being wiped out alongside the dinosaurs 66 million years ago. The discovery of the almost complete tail fossil changed ideas about the Spinosaurus and supported those who believed the dinosaurs spent long periods of time underwater. This discovery is huge. As early as the 20th century, paleontologists had been speculating about marine dinosaurs. One line of thought suggested large plant-eating dinosaurs like sauropods lived in the water, using the bodies of water to support their massive weight. However, none of these theories came to fruition. So the more we find out about the Spinosaurus, the more people get excited that this could finally be the marine dinosaur we'd been looking for even before the discovery of the tail. Ibrahim and his team first released research in 2014, showing that the Spinosaurus had features that would suggest a lifestyle spent largely in the water, like its skull shape and thick-walled bones. Some paleontologists enthusiastically agree with this suggestion. Other researchers were skeptical of these new finds for various reasons, asking questions like, was this just evidence that the Spinosaurus ate fish by wading into the shallows, an idea that was already established by researchers under the wading model? How did it move through the water? Guillermo Navalin, a researcher at the University of Cambridge, suggested that the Spinosaurus moved through a combination of walking in shallow waters like hippos and used its tail to push itself through the water. Naval told journalists he thought this method of moving would be ideal for ambushing large fish like lungfishes and coelacanths. Did newly discovered remains actually belong to the Spinosaurus, or could it be another spinosaurid? These doubts spurred Ibrahim and his team on, and they returned to Morocco in September of 2018. This brutal, tough dig in hot conditions was reportedly fueled by both the hopes of new discovery and team breaks for Nutella. The effort was worth it. And by the end of 2018, the team had discovered over 30 Spinosaurus tail vertebrae. There were several reasons why these were significant. Some of the bones matched up with illustrations first published by Ernst Stromer in the early 1900s. The team didn't find duplicate bones at the dig site, thus the fossils belonged to one individual. These discoveries went to the lab with Ibrahim, who contacted experts like Stephanie Pierce, a curator of vertebrate paleontology at Harvard's Museum of Comparative Zoology, and George Launder, a fish biologist, to help test his thesis. Models were created using the tail bones and tested in water. This research showed that the Spinosaurus tail had a much stronger and more effective forward thrust in water compared to other theropods. This power could have allowed the Spinosaurus to swim against currents and speed up to capture prey. Ibrahim's team has continued their groundbreaking research. They believe the Spinosaurus possibly had webbed feet, so they're looking to reconstruct the dinosaur's foot to see how it moved its toes. This would be more evidence for Ibrahim's theory, which he summarized as contrary to recent suggestions that Spinosaurus was confined to wading and the apprehension of prey from around the edges of bodies of water. The morphology and function of its tail, along with its other adaptations for life in water, point to Spinosaurus having been an active and highly specialized aquatic predator that pursued and caught its prey in the water column. Debate over well, not exactly. Other paleontologists like David Hone, who calls the Spinosaurus a shoreline generalist, have pointed out that being a good swimmer doesn't rule out foraging behaviors. Hone points out that based on what we know, the Spinosaurus could have been unstable in the water, based on the proportions of its body, could have had high drag. Because of its body shape, particularly the sail on its back, when moving in the water, which wouldn't make it easy to pursue fast fishy prey, could have had low swimming efficiency. Ibrahim's paper compares the efficiency of the Spinosaurus's tail for swimming to creatures like crocodiles, but using Ibrahim's data, crocodiles had an efficiency 1.5 times greater compared to the Spinosaurus. And although crocodiles are excellent swimmers, their speed and agility Don't compare to other swimming creatures like fish. Whilst the Spinosaurus was very likely to be a better swimmer than other theropods, it might not have been good enough to keep up with some of its prey home. Also points out that different groups of Spinosaurus living in different areas would have had to adapt to suit their environment, and juvenile Spinosaurus would have again had to adapt to their shape and size, which may have changed the way they haunted. It might not be a case of one size fits. Also, this topic is still up for debate, and who knows, in the future new evidence may cement one of these arguments or point researchers into a whole new direction. For a long time, paleontologists were studying the Spinosaurus from Stromer's drawings, which depicted the Spinosaurus standing upright on two hind legs like other theropods walking on two legs, enabled carnivorous dinosaurs to have long strides. And they could pick up the pace quickly while supported for balance by their strong, stable tails, which is useful for hunting in comparison. Crocodiles, who sit close to the ground and have four legs sprawled out to each side, have trouble picking up the pace whilst running as they shimmy their bodies side to side. And air is shifted between each lung as it runs, which makes it harder for a crocodile to catch its breath whilst running. However, as we discovered more remnants of the Spinosaurus, this idea of walking on two legs didn't make much sense to some scientists. With a long neck and a large center of mass, wouldn't the Spinosaurus just topple over when it walked on land? After the reassessment of Spinosaurus bones, researchers Nizar Ibrahim and Paul Serrano released a paper called Semi-Aquatic Adaptations in a Giant Predatory Dinosaur. Although this paper doesn't suggest that Spinosaurus spent all of its time in the water, it definitely found it was better suited to living large parts of its life in water and on all fours. The Spinosaurus has strong back legs with short femurs, which are much better for paddling in water. It had a center of gravity positioned much further forward compared to some of its theropod cousins. Like some theropods adapted their stance to increase their chances of hunting successfully, the Spinosaurus was evolved to live in aquatic or semi-aquatic lifestyle and to sustain itself on a diet of fish. It's worth noting that this idea about the Spinosaurus wasn't totally new. Some early depictions of the Spinosaurus did show it as quadrupedal, like this picture from 1976, but it was the first full-blown and most renowned study that supported this idea. But this is the debate section of the video, so you know this argument isn't over. The Spinosaurus is a dinosaur of mystery, and it has been for a long time, throwing paleontologists into debates and bringing up constant questions about how it lived. For example, Dr. Scott Hartman, who is a professional paleo artist, found irregularities between the new look of the Spinosaurus in Semi-Aquatic Adaptations in a Giant Predatory Dinosaur and the dimensions listed in the paper's supplementary figures. Hartman wrote the following in his blog: given the facts available, it appears the proportions of the skeleton in the paper cannot be correct, and so the locomotive and ecological interpretations that depended on the proportions must be questioned. Hartman compared the way the Spinosaurus had been reconstructed to animals like gorillas who walk on their knuckles, but there's no evidence a carnivorous dinosaur could walk like this. Hartman's redrawing of the Spinosaurus looks more conventional with larger high limbs. Another paleontologist, Italian André Cowell, created a different model for the Spinosaurus. He drew the Spinosaurus with a larger curve in its neck, which Cowell says would account for the range of motion of a Spinosaurus, and more upright stance. Paul Serrano wasn't convinced about the negative reactions to his conclusions, stating that he found theories like Cowell's and Hardman's to be musings based on little evidence. So the story continues. The tale of the Spinosaurus is still being written and rewritten all the time, even when scientists disagree. That can often help bring forward more research and new discoveries. The Spinosaurus is an icon for many reasons: its size, its habitat, its unusual features. But it's also an unknown in many ways to researchers today, meaning that we have more exciting discoveries to come in the future. Even the discoveries discussed in this video may be out-of-date theories in 10 years' time as more fossils are found and more research takes place. The story of the Spinosaurus is partially the story of a dinosaur and partially the story of scientific research and the twists and turns it takes. There's another reason the Spinosaurus is special, a reason we haven't discussed yet in this video: The Spinosaurus has significant cultural meaning fossils found in